What I want to look at here is have a little look at Lenz's law, or Lorentz force law, for calculating the voltages in a coil that's moving into a magnetic field. So let's just draw our little magnetic field first, using the x's to show going from north to south. Now, I think most people think of it in terms of Lenz's law. So if we've got this little coil, maybe I'll put it in red. We've got this coil, if you like, moving into here. We know the flux is changing, and we can use our right hand rule to go, okay, well, if the flux is increasing and it's increasing that way, then this loop is going to have an EMF produced in it, an electric field produced in it, which is going to produce a current flow, which is going to produce a magnetic field, which is going to oppose the change. So to oppose the change, we need a magnetic field which is going to come out through the loop. So to do that, our right hand rule tells us that the current's actually going to have to go this way, right? Go around that way, anti-clockwise. So I think we're all good with there. That's the Lenz's law approach to doing this, using the right hand rule. But if we look at it from the point of view of the Lorentz force law, then the electrons in the wire here, we're moving with a velocity to the right, they're going to experience the Lorentz force. So field goes that way into the page, velocity is that way, and positive charges will be pushed up. So positive charges will be pushed up. We're going to get an EMF like that, and if we get an EMF like that, the current's going to flow that way. So you can see we actually can use the Lorentz force law, or we can use Lenz's law to determine the fact that the current's going to flow this way. Now, I'll quickly draw another magnetic field and discuss what happens when it gets into the middle. So we've got a same situation. This loop is moving, I'll make that a little bit bigger. This loop is moving to the right. What happens when it's in the middle? Moving at a constant velocity. Now you're going to say with Lenz's law, flux is not changing, constant field, flux is not changing, no EMF produced. How does the Lorentz force law look at this? Well, we just decided that this one was going to produce a voltage like this, using the right hand rule, and look what happens on this side. This one also will now produce that voltage. They're going to cancel out, and again we're going to get no current flowing. So you can use either Lenz's law or the Lorentz force law to determine the direction of current flow in a loop moving into the field.